Hello, my dear friends. Welcome to the subject of statistics for the class 12th English medium, part 2, chapter 5, differentiation, presented to you by Vitan sir. Let me ask you a question that for any business, we know that earning maximum profits by maximizing revenue and minimizing cost is the primary objective. That means if I want to earn maximum profits, I need to increase my income and reduce my cost. Then, what if we can find out the exact number of units to be produced for this purpose with just pen and paper? That means without going into the market, without actually selling or producing anything. What if we know that by producing exact number of units, I can earn the maximum profits, maximum revenue, and I can also minimize my cost? What we need to do in this tutorial is calculating maximization of profits, maximization of revenues, and minimizations of cost. Now, we have already learned how to maximize or minimize an equation, okay, that we have learned in the previous tutorials. What we need to do now is we just use cost, revenue and profit equations for the same purpose. That means we will just use maximization and minimization of equations method on cost, revenue and profit equations. That means to minimize cost, we need dc upon dx to be 0 and d square c upon dx square to be more than 0. Okay, this is the rule. These are the conditions which I have mentioned for maximization and minimization. We are just applying those conditions to cost, revenue and profit. We need to maximize revenue. That means dr upon dx will be 0 and d square r upon dx square will be less than 0. Okay, to maximize we need less than 0, to minimize we need more than 0. To maximize profit, dp upon dx will be 0 and d square p upon dx square will be less than 0. Okay, now these are the only conditions which we need. Maximization, minimization we have already done. So let us take some illustrations and understand how to minimize cost, how to maximize revenue, how to maximize profit. Illustration 32. The daily cost of production for x tons of commodity is 10x square minus 1000x plus 50,000. Okay, we have the cost function here. How many units should be produced for the minimum cost? So we need how many units to be produced. That means we need the answer of x. Also find the minimum cost. Okay. First of all, I will write down the cost function, that is 10x square minus 1000x plus 50,000. Next, I need to calculate its differentiation. 10x square will be 20x, 1000x will be just 1000 and 50,000 will be 0. So my derivative is 20x minus 1000. Next, I need to take dc upon dx as 0. That means 20x minus 1000 will be 0. I will change the side of 1000. So 20x is equal to 1000, and when I take 20 into the division of 1000, 1000 divided by 20 is 50. So x is equal to 50 is the only answer. But let us check whether this will be the maximum or the minimum. Next, d square c upon dx square, that is 20x minus 1000. So 20x becomes 20, 1000 becomes 0. So 20 which is greater than 0. So function will be minimum. When the second order derivative is greater than 0, the function will be minimum. So production cost will be minimum at x is equal to 50. And putting this x is equal to 50 in our original cost function, that is c minimum will be 10 into 50 square minus 1000 into 50 plus 50,000. To simplify, 10 into 2500 minus 50,000 plus 50,000, and your answer will be 2500. So to get the minimum cost, I need to produce 50 units, and the minimum cost which I will be incurring is 25,000 rupees. Okay, so this is how we calculate the minimization of the cost function. Let us take one more illustration and understand it better. Illustration 33. A factory produces X units and its production capacity is 60,000 units per day. Okay, that is just the maximum production capacity. That is of no concern to our calculation. Its daily total production cost is given 2,50,000 plus 0.08x plus um, 2000 some zeros divided by x. How many units should be produced for minimum production cost? Okay, now first of all we are going to write down the equation as it is. Production cost function is c is equal to 2,50,000 plus 0.08 x, 20 crores divided by x. Okay, now what we need to do is we need to find the dc upon dx here. 2,50,000 is just 0.08x is 0.08. Now when x is in the division and we need to differentiate it, it becomes 1 upon x square, but that is negative 1 upon x square. Now this is something which I have taught you guys in the very early tutorials, so that we have to remember how to do that. 1 upon x is negative 1 upon x square. That's the direct answer. So 0.08 minus 20 crores divided by x square. What we need to do is we have to assume dc upon dx is equal to 0. So 0.08 minus 20 crores upon x square. We will change the side of 20 crore upon x square. What we are going to do next, we will change the x square in the numerator and 0.08 will come in the denominator like this. So x square will be something still more, and then x is 50,000 or x is negative 50,000. Now how did we come to this? When we are squaring a value, whether it is positive or negative, the answer is positive. So right now x square is a positive answer. So when we find its root, it can be positive, it can be negative. There is no reason that it should be positive or should be negative, but because it is a production, it cannot be negative, so we will take x is equal to 50,000. So x is a production unit. Now production cannot be a negative value, so we will take x as not negative 50,000 but positive 50,000. Now next we have to take out the second order derivative here. X square was there in the first order derivative, so it's a derivative, 1 upon x square derivative becomes 2 upon x cube. So 20 crore becomes 40 crores and divided by x cube. That is the second order derivative here. So when we put the value of x as 50,000 into the equation here, it becomes d square c upon dx square is equal to 40 crores upon 50,000 cube. No matter what is the value, it is positive. So positive is greater than 0. So production cost is minimum at x is equal to 50,000. Now the question is that we don't actually need to calculate the production cost. We just need to find the value of x for which the production cost is minimum. So I am not calculating putting the value of 50,000 into equation. I am just saying that production cost is minimum at 50,000 units. So if I produce 50,000 units, I will get the minimum cost. Okay. Illustration 34. The demand function of a watch is P is equal to 6,000 minus 2x. Okay, that's the price. P, small p is price, capital P is profit. Remember that. Find the demand for which maximizes the revenue and also find the corresponding price. Okay, so first of all we will write down the demand, that is P is equal to 6,000 minus 2x. We need the revenue here, and revenue is x multiplied by P, that is x multiplied by 6,000 minus 2x, that is 6,000x minus 2x square. So the revenue function here is 6,000x minus 2x square. We need to differentiate this. We will get 6,000 minus 4x. Okay, so the differentiation for 6,000x minus 2x square is 6,000 minus 4x. We have to take dr upon dx as 0, and that means that 6,000 minus 4x will be 0. We will change the side of 4x and then take 4 into the division. We will get x is equal to 1,500. Okay, we only have one answer, but let's check whether this will be maximum or minimum. We need to find derivative for 6,000 minus 4x, that is the second order derivative, that is 0 minus 4, and negative 4 is actually less than 0. So whenever second order derivative is less than 0, revenue will be maximum at x is equal to 1,500. So putting x is equal to 1,500 in the price function. Why? We also have to find the corresponding price, that means price when x is 1,500. So P 6,000 minus 2x, that is 6,000 minus 2 into 1,500, that is 6,000 minus 3,000, that is P is equal to 3,000. So if we produced or if we sell 1500 units at 3000 rupees price, we will earn the maximum revenue possible. Okay, units are 1500 and price is 3000 to earn the maximum revenue. In the question, we are not supposed to calculate the maximum revenue actually, so we will not be doing that. Moving on to the last illustration of the chapter and this tutorial. Illustration 35, if the production cost function for a producers is cost 100 plus 0.015 x square and the revenue is r is equal to 3x, then find the profit function. Okay, now this is a question which is about calculating the profit. Okay, how many units should be produced by the producer for maximum profit. Now here we have to use a common sense. What is profit? Profit is the difference between the income and the expenses. Here income is the revenue and expense is the cost. So capital P, profit, is the difference between revenue and cost. That means we have to subtract both the functions here. That is profit will be 3x minus cost function, that is 100 plus 0.015 x square. When I remove the brackets, it becomes negative. So 3x minus 100 minus 0.015 x square. Now I have to do all the works with this particular equation here. So I will calculate dp upon dx, where 3x becomes 300 becomes 0 and 0.015 x square. So 2 comes into the multiplication, so 0.030 x. Simplifying it becomes 3 minus 0.03 x. Now dp upon dx is to be taken as 0. So 3 minus 0.030 x will be 0. Changing the side, 3 is equal to 0.030 x, and when I take 0.03 into the division of 3, x becomes 100. Okay, now I have to check whether this is okay or not. So 3 minus 0.030 x will become 0 minus 0.030, which is negative 0.03, which is less than 0. So x is equal to 100 will maximize the profit function. Now the question was not asked for calculating the maximum profit, so that we are not going to do. What we are going to do is we are going to end this sum with this answer, that when we produce or when we sell 100 units, our profit will be maximum. Okay, so with this I end my tutorial here. Our chapter number 5 differentiation also ends here. In the upcoming tutorials, I will come up with some specific sums from the final exercise of this chapter, which might be difficult and which are the most IMP for the board purposes. So till then, stay tuned and see you soon, my dear students.